Good morning and welcome to our today's webinar. My name is Victoria Tuzova. I'm Business Development Manager at Elecard. So we will talk about low latency GRC data delivery protocols such as RIST and SRT that have gained a great popularity lately. What common foundation do RIST and SRT have? What is the difference between the protocols and when you should pick RIST over SRT or vice versa, for example? These are the main key questions that are included in our agenda today. I would like to give you just a quick note that we will have a live Q&A session at the end of the presentation. So please feel free to ask your question during the event. You can leave your questions in the Q&A tab and click submit for us to be able to track them. So also I would like to know that the session will be recorded and sent you within a couple of days. Well, let's start. Today, Elecard and VideoFlow teamed up to share their experience with you. So let me share just a few facts about the companies. Well, Elecard is the company that develops and provides video compression solutions, analysis of media streams and compressed video bit streams, and QNS and QNE probes for real-time monitoring. VideoFlow is a company that develops products that allow to broadcast over any IP network, including over the internet. And please let me share some few words about the speakers and experts who joined us today. Vitaly Sutorykhin is a head of integration technical support at Elecard. He leads and heads the largest projects at Elecard. Adi Rosenberg is co-founder and CTO at VideoFlow and RIST Forum Director. He's involved in promoting secure and reliable video delivery over IP networks worldwide. Well, colleagues, thank you for being with us today. We have a very curious discussion panel today to cover advantages and disadvantages of the protocols, security and encryption, common foundation and difference. And of course, we will make a kind of a forecast for both protocols. So let's jump to the question section. Vitaly, this question is for you. Just let's begin. So why are we talking about RIST and SRT today? And can you please list the main advantages?
Sure. Hello, everyone. Actually, currently, there is a high demand at the market for delivery and for contribution of high-level content of high quality, but without any losses via public networks with a low delay and probably some encryption add-in. So actually both SRT and RIST has low loss protection mechanism that are integrated into the implementation of the protocol and can allow to do both not even low latency, but even lossless streaming via public network. And actually, they are pretty similar, but they have some differences that we'll talk about later. And Adi, probably you want to add something?
Yes, basically the two protocols came to solve a problem in the market. Till 2017, there were proprietary protocols out there, and the market required something which would be open source, open spec. And this was what came to be SRT, led by High Vision, RIST, which is the brainchild of the Video Services Forum. And the two protocols address the same problem, slightly with a different approach. And I believe that we will touch base on the subtle differences between them. And the table in front of us can definitely, to those who can read it, can definitely see the subtle differences between the two.
Yeah, so basically that's it. And I want to mention that, like Eddie already mentioned, It's the main advantage of these both protocols is that they have open source implementation. They have already libraries that everybody can implement in their own solution. And actually, any realization implementation of RIST or SRT can be interoperable with each one and fully compatible. It's quite important.
Okay, and maybe you can mention like, okay, you mentioned such words as integration and compatibility, and how about the compatibility issues that can occur that we should expect? Maybe Vitaly?
Yeah, since this protocol are quite transparent and pretty easy to use from the first glance, but obviously it doesn't work this way in actual implementation on the customer side, since you need to join two different points and you can't just launch the sample from LibRIST or SRT library. You need to make it work in different situations, different circumstances, and there may be some variables like jitter, like some variable packet loss, where the percentage of this packet loss is variable. Probably you want to create some multi-link or bonding. You want to create probably some backup source and backup route of the traffic. So in every case, in every scenario, you need to fully understand how it works in order to operate it correctly, in order to configure it correctly. Since public network has too many variables and the behavior of your stream may vary from time to time, from day to day. And the main point here is to have a responsible and reliable partner with whom you want to integrate and with whom you want to go inside the, your current project.
Okay.
So,
Adi, do you have any comments to add?
Well, I think Vitaly said it all. It's not only selecting the protocol that you want, but you also want to select a partner. The partner that did the integration or can provide you professional services and has the expertise to do the work. I will use it like when you buy a car, you don't only buy a car, you also buy the service that comes with the car, the mechanics. How can they provide you the support when something breaks down? So that is why it is very important to choose the partner in crime, in that sense, to follow you, to be with you and help you along the way. Neither SRT nor RIST are simple as you would imagine FTP or SSH, which you just take and use. Both are there. You need to know how to configure them. You need to know how to debug when you have problems. And the selection of partners is important. You need to know how do you design the product, how he designed his product, or how does he know the behavior of networks and equipment to assist you if something goes wrong.
And if we're talking about behavior, network, and assistant and everything, we can jump to the question about security and encryption. Adi, could you please share your thoughts on security and encryption, and maybe what of the two protocols are more reliable, probably?
Wow, this is a very big question. So SRT,
sure.
SRT chose a very sophisticated PSK encryption. PSK stands for pre-shared key. So as those who know how to use SRT, you basically select a passphrase and it is being then used by the encryption protocol. The RIST, on the other hand, went with two different paths. One path is a standard DTLS, which comes with authentication, not only encryption, but also authentication of the 2 points. But it also went to has an option to add a PSK, which basically comes with LibRIST, which is the open source. The PSK is similar in its nature to the SRT, but the RIST felt that the PSK is not good enough. So it added layers like dynamic key rotation or exchange of keys. Change of keys need work to enhance and beef up the security. And in that sense, it's the RIST is slightly better in security than, sorry, the RIST is better than the security of the SRT, but SRT is making head and strides to add more and more security, which is required by this industry.
Okay, thank you. And Vitaly, I know that you have like an experience in researching both protocols, and I would like to ask a question. How did you monitor the quality of this like streams, these protocols?
Yeah, I just want to add to the previous question that
Sure.
From my experience, if I'm not mistaken, Adi, please correct me if I'm wrong, that RIST moreover has a firewall mechanism for unwanted traffic, and it just integrated into the implementation of the protocol. And moreover, about reliability regarding monitoring as well. From my experience, from my tests, and from what I have read in the open network researches and etc., SRT can recover up to 15% of the traffic loss, but RIST can recover up to 60% of the traffic loss, which is quite huge. And this reproduces in my tests. And I've just used our product Elecard Borrow, which now has SRT support in alpha mode and RIST support on the basic level, on the level of receiving RTP. So it's pretty safe to say that RIST now, just for now, is more reliable, but probably it will change in the nearest updates. Who knows? Let's see.
Can you go one slide forward so we will see what Vitaly is talking about? Yes, this is basically touch bases to what Vitaly was addressing. So you can see here that the comparison that was made from known sources and also from test, lab, and field, you can definitely see the difference in the certification authentication, the packet loss recovery. Vitaly mentioned the firewall. Because the RIST may be used as a bidirectional protocol in its main profile, and we have a slide for that, then you don't want to open your tunnel to somebody to hack into, to breach into your device or system. So RIST from day one insisted on a firewall to block unwanted traffic. So that is basically where the RIST is coming from. I'm not here to represent RIST. I'm using both protocols in my product, so I can talk about both. And just Vitaly said, right now, SRT and RIST are trying to basically come up with the same features. RIST on paper has more richer features than SRT, but SRT has what is called the release 1.5 that we are waiting for, that will bring bonding, will bring an official SRT tunnel that we are waiting for it to come up. So SRT will bring, at the end of the day, some of the features that are now available with RIST, but also RIST is also adding more features that we are not going to touch base on because they were not made public yet. And if you can go forward, go to the next slide, we can show the basic difference between RIST and SRT so people can ask questions. So in this slide, you can see the RIST tunnel. This is the main profile, or in libRIST, this is the protocol 2, sorry, type 1. This is P1, where you have basically just like with the SRT. In SRT, you have a caller and a listener, and we have a slide on that. We have in a RIST, there is a client and server. they create a secure tunnel. When a secure tunnel is established, it can be bidirectional, and it can be used with multiple streams being sent back and forth, but not only streams, but also any type of data. HTTP, SSH, ICMP, SNMP, whatever you can think, the tunnel can push to the other side. And this is why firewalling that traffic is very important.
Okay.
Okay. Now let's see the next one. We will compare that to an SRT. And basically, once again, we have a client, which is called the caller, a server, which is a listener. They create a secure link. It's a unicast secure link where the client and server can send usually one session, one stream, either one way. But there are implementations today that I know of. For example, AWS that started to use a new feature that was not used before, called Stream ID, where you can multiplex multiple streams into one connection. This feature is used, for instance, by AWS Media Connect, and we will have a slide on that. But you can see that on the face of it, the connectivity looks similar, but there are subtle differences that one may look into when selecting what protocol. The direction of traffic, you can also see, it doesn't care whether you're a server or a client. You can stream which way you wish to do so. Take it away.
Okay. With the next one.
Can I take this?
Adi?
Yes, thank you. So this is an example of, to those who are not familiar with the AWS Media Connect, which is a solution to contribution and distribution from the cloud. It was initially launched 2 years ago with the Zigbee protocol, but now it is offered also with the RIST and SRT. So a vendor like AWS can receive and send by any time with any protocol, open source protocol available in the market. And this is just an example of application.
Okay.
So to those who want to see the main difference between SRT and RIST, it boils down to the next slide. In this slide, you can see a single tunnel, and you have different senders and receivers using the same tunnel, sending data traffic back and forth. This feature right now is missing from the SRT, from the latest library 1.4.3, where you have to connect, you have to create a tunnel per session, per stream that you are sending. Also, you cannot send other type of traffic through the connection. That means that you will have to open several ports in your firewall in order to achieve the same task. Go next. This is an type of an example that was that VideoFlow demonstrated a few months back. We have that working. This is a remote camera sitting, in this case, it's in Australia, when we have an encoder with the RIST client. And here we bring another feature of the RIST, which is right now missing from the SRT, is the ability to do bonding or load share. In this example, we demonstrated a real use of a 5G network in parallel to an internet connecting to a remote receiver. And in the meantime, hooking up a PTZ controller on the receiving side to command a PTZ camera on the left. So we are bringing two specific RIST capabilities to bear that are currently missing in SRT. But be sure that according to the latest announcement by High Vision to the SRT Alliance, 1.5 is coming, and its main focus is on bonding. So I do believe that such capability will be available once version 1.5 will be available to the market. But right now, only RIST can give you this functionality. Now, why is this functionality important, you might ask? Is because you cannot rely on only one connection. You want to spread the link or duplicate the link or spread the stream that your important stream between multiple links. So if one is having troubles, errors, or packet loss or disconnect, you still can continue seamlessly and not doing a switchover. If such an application were to be using SRT, we will need to have 2 sessions, and then we will have to switch between them. The switching creates impairments, visual impairments. And of course, a third link will be needed to control the PTZ camera. So that is one of the big things that the SRT today is missing in its portfolio of capabilities. Let's go to the next slide, please. And this is another example that is what is diverse path and load-share bonding. In this case, the stream not duplicated, but rather 90% is sent over Wi-Fi and 10% is sent over 4G, so that 100% hits the receiver on the other side. This is where RIST shines, and SRT is still on the fence waiting. Okay, go forward.
Mm-hmm.
This is an example of application that was demonstrated a few years back when RIST started. This is an application by Menkin Media out of the US, in Tennessee. And they were one of the first companies to embrace RIST into their workflow. They were doing acquisition using encoders, in this example by Cobalt, and they were sending the feed for transcoding in their facility, and then feeding that to the cloud. Also, they were sending back the feed over the same link for local monitoring at the venue. And a third link was to do monitoring, live monitoring, with the help of tools like Data Miner by Skyline, and a tool called a service that the Menkin Media calls a Guardian service to monitor all the components in the system. And for that, they embraced RIST from the get-go. They even started with RIST before there were specifications, because the companies that provided the solution, in this case, it was Cobalt and VideoFlow, gave them that opportunity. So it enriched their capabilities.
Okay, Ari, thank you very much for such detailed use cases. It was very, very interesting to see your experience, and thank you for sharing your experience. Before we jump to Q&A session, I have question from the another angle about the commercial side. From the commercial side, are there any license restrictions or any maybe hidden cost using SRT and RIST? Vitaly.
As far as I understand and as I know, 2 licenses are pretty common and free, totally free.
Mm-hmm.
You just need to mention that you use SRT or RIST when you develop your product, but it's actually this. Probably Adi has some comments about this.
Well, to supplement, if you are a user, if you're a broadcaster or a user, you should not care. You can use SRT or RIST. It's open to be used. Of course, the vendor that you buy maybe have a license for that, but it's a totally different issue. With the SRT, there's the SRT. With the RIST, there is an open source LibRIST that you can download. It's free to use. If you are a manufacturer, then there is some, you may need an approval from VideoFlow. You just write me an email, say that you want to use RIST, and I grant you the use of that, but there is zero royalties on using either protocol.
Mm-hmm. And Adi, like previously you mentioned some points about the roadmap for RIST and SRT. Do you have any other comments regarding the roadmap or maybe about the future of these two protocols?
Yes. So SRT today, as I mentioned several times, is looking for, right now we have a very stable version 1.43 that fixed a lot of problems that we saw in the last 8 months since 1.42 was pushed to the market. The High Vision and the SRT team of developers did address many issues that were annoying. And 1.5 is a work that's being done, and the bonding is supposed to be very good in terms of the implementation of that, to be very dynamic in its nature. So it is available in the nightly builds to those who are, want to be an early adopter, but I will argue that wait for 1.5 to be available. With RIST, there is a very rich roadmap. Right now, the VSF RIST activity group, which I'm a member of, is working on releasing the next profile, which is an advanced tunnel. This is going to be released in the coming days, weeks. And the advanced tunnel is a new concept. The concept is that the tunnel itself will be you will protect the tunnel and everything within the tunnel. So the traffic may be UDP, HTTP, TCP. The tunnel itself will provide you the protection. So it frees your implementation of sending data. It's a very advanced thing that also is adopted by the ST2110/1 group. So it will become more professional. It's also doing 32-bit RTP sequence numbers. It is already targeting the high speeds of 10 gig or even 20 gigs of content that need to be run. Additional security were added. A concept of a relay is going to be added. And they also, a TR0604 is being also worked on that will add adaptivity, will add a lot of configuration, but I cannot talk too much about that because that's only on the roadmap, and officially I cannot talk about this publicly.
Thank you, Vitaly.
Yeah, and I have some question and suggestion at the same time. As far as I know, RIST plans to implement such called hybrid TV support, like in ATC 3.0 or like in hybrid TV among the Europe. Am I right that this will allow to, just you already said, to send different types of traffic and vice versa to different points? And it's what is all about.
Yes, this is actually true. The whole notion of the RIST is that many companies come together, those are vendors and users, and they define what is the roadmap for the future of the industry. So a group of experts sit down on twice a week, even more, to see how to design a protocol that will meet those goals. Some of them are maybe crazy, but if they are putting in writing and the use case is there, then the group works to see how can be implemented, and that goes to a specification. And in parallel, it is already being added to the LibRIST for newer versions of Libris to be included. So that is how we in the RIST group see that.
Yeah, and some additional information that I've found while preparation for this webinar. As far as I know, SRT and 1.5 will also just, I believe, support multicast traffic and such called metadata exchange. I think it's more about some data about the current status of the stream, right?
Yes.
And some bandwidth control, which it's right now where RIST shines. Let's say it can just get off some different overhead during the streaming, and probably SRT plans to do something similar in its next release.
Yeah, you do need to understand that many vendors of the RIST are also members of the SRT Alliance. For example, High Vision was a member of the RIST group from day one. They even pitched the SRT for when the RIST activity group was started. High Vision pitched the use of SRT, but other vendors felt that the underlying UDP protocol was not good enough for live streaming, and they opt to go with RTP. And personally, I think that if High Vision will add RTP as the underlying protocol, it can make wonders and great things to the SRT and unify both protocols, because as you mentioned, the roadmaps seems to be very similar. A technical guy may say that SRT is trying to copy RIST. RIST may be theoretical and SRT is the practical thing, but I think that in 2 to 3 years, most of the capabilities will merge. And then the difference will be what will be the speed, how good will they deal with the like JPEG XS that needs a lot of bandwidth, going to the cloud, from the cloud, all of these things will come into play. For example, going back to the slide that talks about bitrate, one of the unknown limitations of SRT today is that it can do up to 90 megabits per stream, while RIST can do 200. RIST today can do 200, 300, depends on the implementation, on the bandwidth. So as soon as 1.5 will come and some of restriction will be lifted from the SRT, we will see more and more capabilities, shared capabilities available to the market.
Yeah, and just to continue your idea, I have some popular question that I'm asked about that. What do you think about merging SRT and RIST into one protocol in the future? And from my point of view, it's kind of possible. And what do you think about it, Adi?
I'm a big believer, as I said, that if the SRT group will, if they can take away the UDT, the underlying UDT protocol, and replace it with the RTP, then the two will the RIST and SRT will converge, because after all, it's just signaling, and we can just create a signaling layer to overcome that. I was quoted saying that it will be SRT 2.0, and I do think that is something that the industry really need.
Got it. Thank you.
Thank you. Well, we have some question in Q&A tab, so please let me proceed with the questions that we have from attendees. Well, the first one is, any plugfest in RIST to take care of interoperability?
Well, actually, there is something running for the last 2 months. There is a RIST server that is, and the company is waiting for people to come to test their RIST implementation against that plugfest. Usually, usually during the video services from face-to-face meeting, which is happening in February, which is called VTrans, there are FlagFest and interoperability tests between vendors. They test and fine-tune their implementations, because this is something that also need to remember. Many companies have their own flavor of RIST implementation. Just like some companies have their own SRT implementation that they went and fixed issues or enhanced capabilities in the SRT code.
Vitaly, any comment? Let's go with the next question.
Yeah, I think it's just a common case where you just need to know the current task, all the needed options to implement, and basically RIST vendors and SRT vendors are compatible between each other, but when it comes to details, it may differ.
Mm-hmm. And we have another question regarding Zigbee. Where is Zigbee going? I think, Adi, it's regarding your like real world use cases.
Zigbee or Zigbee?
Zigbee.
Zigbee.
I believe it's Zigbee. Yeah.
I noticed some satellite receivers have Zigbee built in. It's proprietary.
Okay. So I cannot comment for Zigbee, although I'm a Zigbee partner, but Zigbee is a protocol. Zigbee implemented into their solution, into the taker, also RIST and SRT. So just like Vitaly said, there are many vendors that implemented a proprietary protocol, RIST protocol, SRT into their solution, and that may be offered. You might want to check with the vendor that you're using the solution, the product that you bought, whether it can be upgraded to support all of them from latest upgrades from Zigbee, but that is a commercial agreement between the vendor and Zigbee in that sense.
Mm-hmm. And Vitaly, let's have the next question for you. RIST seems to have some more functionalities than SRT right now, but the next release of SRT may fill those gaps. Will SRT continue to be the leading protocol then? Those are very interesting. So maybe like you can answer this question.
Yeah, I think it's pretty safe to say that right now, most of the market is dominated by SRT for understandable reasons, since SRT was implemented first. But in the nearest future, things may change. Let's see. From my point of view, I've expected the latest release 1.5 in the previous year from SRT, but it didn't come. Hopefully this year we'll change it. And like you've said in your question, most gaps like multicast absence will be covered, but let's see who'll win. Right now, nobody knows for sure. And probably Adi have some comments about this question.
Sorry, I missed you. Can you repeat that?
Just the question, the main idea, if SRT in the next release will cover all these gaps, like multicast absence, like multi-link support, will the SRT remain the main and the one protocol at the market, or probably RIST may win over the SRT?
There is no, as I said before, there are many vendors have SRT or RIST, or they are going only one direction, having only SRT because they downloaded the code. It takes like 2 hours to add it to your product, and you are done. You take the SRT live transmit, you do some configuration, and you think that you are done. I do believe that 1.5 will be a very big breakthrough for SRT to supplement on the things that were preventing it to become great. The current version 1.4.3 fixed a lot of things that were very annoying to the industry. Justin, I'm not going to talk about the problems, but I will give you an example. In my product, I couldn't use SRT continuously more than 1 day of streaming. It would break down, and I had to restart that. And that was a problem that is now assumed to be fixed in 1.43. If you are doing 1 hour to 2 hour streaming, SRT is great. If you have a very good connection, SRT is great. But you can't rely on something that you just tested in the lab and hope that it will remain the same on the internet, whether it's public, private. The network is dynamic, and the protocol is there just to assist you. You have to monitor it, you have to maintain it. You need solutions like from Elecard to monitor how the health of the stream when it goes out, going in, going out. So as you said, I think 1.5, SRT 1.5 is something that we all in the industry are waiting for. It will make SRT better than before. All the shortcomings that the RIST community was poking at the SRT, most of them will be gone at that stage.
Yeah, but actually it will take some time anyway to implement 1.5 and test it. So it will definitely take some time. And regarding the previous question about Zigbee, actually from my point of view, from my perspective, SRT and RIST both came in order to replace the Zigbee since it's proprietary. And moreover, probably in future, SRT and RIST will replace even satellite receiving from perspective of contribution from content provider, let's say to CDN. So things dramatically changed last year. 5G comes, and who knows what we will see in the future in the nearest 1 or 2 years. So it's kind of dynamical.
Okay, Colin. Sorry, Adi.
No, next question, please.
Yeah, sure. We have a lot of questions. So let's proceed with the next one. Adi, this is personally for you. Hello, Adi. I think to provide tunnel from public broadcaster to private prem might be backdoor in our security system. Could you comment that?
Yes, that is touching base on the security aspects. So when you are doing that, when you have a tunnel, insist to have the best solution possible. Where if it's with RIST, use a DTLS with authentication. Once you have authentication, that prevents somebody else of breaking into your system. But then we're also not assured that if the other side didn't protect its rear, somebody may breach that device or software and can still break into your system through the tunnel. This is where the firewall comes into play. Most implementations require to implement some kind of a firewall or to limit the use of several IPs. So simple implementation will allow only one type of IP to pass through. Others will block full IPs, ports, IPs, protocols. It then becomes a implementation thing. And usually the vendor that provides you the solution, you will need to hook him up with your IT department, and you need to do a pen test to verify that everything is A-OK. Now, with SRT, there's also that possibility. It is just not that publicized. It's not that open and apparent when you use the standard SRT. There is a backdoor. Just like with people using TeamView. Somebody can go, TeamView is bidirectional communication. So there is the possibility that somebody will hack SRT also into your backdoor. The only problem is that people are not aware of those backdoors, and your IT department should do pen tests to verify that you are safe and secure.
Okay, thank you. The next question is for Vitaly. Vitaly, do you already have an encoder with direct support of RIST as an input and output?
Yes, actually, Elecard CodeCorks, our transcoder and encoder, already have RIST in its pre-release version. We need some time to test it and to implement some deep features like multi-link and etc. But for now, point-to-point RIST already works, and we just tested it in our lab, and 60% of packet loss and total recover of any packet that we lost is true, and it actually works. Actually, during this test, we used the same network interface for SSH access and for streaming, and actually SSH didn't leave, didn't come out after 60% of loss. But yes, it works, and it's actually unbelievable from my point of view. Probably public internet can be so lossy if you just don't transmit from Siberia to, let's say, Australia or let's say USA. But anyway, it works, and it's kind of impressive.
Thank you. The next question. What's about CPU overhead to initiate and run RIST versus SRT? Adi.
Well, I think they're quite the same in nature. There's not that CPU power difference between the two. The only thing that RIST may take more is will be memory. If you need to have a long delay, like SRT is limited to 4 seconds. If you want to do like 30 seconds delay because you want to run from Siberia to Australia and overcome sudden losses, then the SRT will use a bigger buffer, which is tied to the RTP sequence number. So then it might take more megabits, but it's not in hundreds. This is like several megabytes bigger. But on CPU, it's almost the same thing.
Okay, thank you. And the other question is from Norman. He asks, I have 16 UDP multicast point-to-point or multipoint. Do I just need a server at each point with Elecard of video flow software? Colleagues, any of you?
Well, I think this is a particular case. I don't think this is if you have an SRT, you will need to have 16 connections. I don't know I'm not familiar with the Elecard implementation. If they're using the standard SRT live transmit, then they will need to have 16 different sessions to do that. If they will use like a video flow software, they will create one tunnel and send those 16 streams across. Each one will be protected with the RIST. Hey, just a joke. You can use an SRT and send it through a RIST tunnel and provide protection over using SRT inside RIST. Just this is a joke, but it is doable.
Okay, thank you. Let's proceed with the other one. Is how many vendors have implemented RIST for input and output?
Good question. Today, I know of about 10 to 12 different RIST implementation, meaning that different implementation coming from different source code that did interoperability tests. The reason for that is that the underlying RTP was the foundation, using standard RFCs to add all the layers like GRE, UDP over GRE is a standard RFC, using DTLS is standard. ARQ, there's a simple explanation in the specification. How do you do that? How do you build your buffer? But there are many others that took the LibRIST and are using that in their implementation. So unique implementation, I believe that 10 to 12, counting LibRIST inside also.
Yeah, and as far as I know, just RIST is just RTP plus RTCP for controlling and just some retransmission, SMPT 2022 for seamless switching, for forward error correction. So basically, all these specifications are already well known and they are already implemented. And if we talk about total vendors that have already implemented RIST, please correct me if I'm mistaken, Adi, it's more than 150 at the moment. 150 are actually the number of total members in RIST forum, and I believe every one of them already integrated RIST in their solutions.
Or using RIST, yes.
Mm-hmm.
And there are many that use RIST, but they just don't know that it is RIST inside. They may be using Zigbee with RIST, and they think they're using a Zigbee protocol, but it may be RIST. I know that other protocols just change the name of the protocol to other something under their name. So the user doesn't know that he's actually using RIST inside.
Yeah, you can receive RTP, but it can be RIST. And you can just see the continuity counter, but it's the actual packet retransmission. So yeah, this way.
Thank you. And the next one is, are you familiar with R2TP protocol from Kaiton Technology?
Vitalio, me, I know Kaiton.
I don't know about this technology.
Mm-hmm.
Most probably it's similar. I need to find out right now. I can say that.
I can take that. Kaiton
Please proceed.
R2TP by Kaiton. Kaiton has been around for the last 10 years. They also it's a proprietary protocol based on our underlying RTP. It's their own proprietary thing. If somebody wants to see the behavior of R2TP being tested, I propose that you go to the YouTube, type R2TP. You will find a Chinese channel that compares R2TP to SRT and RIST, which is quite professional, although it is in Chinese, but it has a translation, and you can see a very professional comparison. R2TP or Canon are very known in the Far East, in Asia, and so I know of them, and good people.
Okay. The other one is like a combined question. What is the maximum SRT and RIST bitrate, and what is the difference between RIST profiles?
Whom?
Let's give the floor to Vitaly.
Okay. If not mistaken, SRT is limited up to 90 megabits per second, and RIST has no limitation. But in addition to this, I need to mention that when SRT detect any packet loss, it can be huge traffic spike. It tries to recover all the loss, and it's not like step-by-step traffic increase. It just a huge spike, and it may affect the quality of the stream, and it may be the bottleneck of the actual streaming. But when we talk about 8K streaming, probably RIST will shine here, or probably some not media streaming, let's say some files transfer and etc., which SRT is also capable of. But in this case, it's all about traffic you can afford. In most cases, when you use public network, you can't rely on even more than 10, let's say, or 20 megabits per second. And here they are kind of similar to each other. And Eddie, probably you have some comments about this.
Yes, I will address the RIST profiles. So today there are two published profiles, TR0601, which is called simple profile, This is a basic unicast, multicast RTP stream with a layer of protection that also adds a forward error correction, bonding and load share, and as you mentioned, transmission throttling so that you don't burst your ARQ immediately. The next profile is the main profile, TR0602, which added the tunneling. The tunneling provides a security by way of DTLS and PSK, also authentication layer. So you can now authenticate who is connecting to you. You can connect, you can reject a connection, and also there is metadata exchange. Another thing that was added to the TR0602 is the capability of null packet deletion, which is removing of null packets in a transport stream to have some gain of bandwidth. This is, by the way, another thing that is supposed to come in SRT 1.5. As we stated, we are waiting for that. The next protocol that I mentioned is the TR0603, which will be the advanced tunnel. Following that will be a TR0604, which will have advanced capabilities like adaptive streaming. So you can throttle the source to change according to the network conditions. Sender, or actually receiver synchronization, network management. And there's a full list of capabilities coming with that. I can tell you that the work is being conducted for almost 18 months already on the last two ones.
And Adi, I have a question about advanced profile or enhanced profile. I see in the roadmap such called centralized call home. What is it all about and what does it mean? Could you please clarify?
Okay, so when we have a call, when we have a client, a server, or we have a caller and a listener, the client will call home. Call home means it will try to connect to the server or a listener in the SRT. So regardless where the client is locating, whether he is using cellular or switching between cellular to LAN, he will be able to establish connection to the home, which is the server, to a unique IP or URL and a unique port. This capability is shared by both RIST and SRT. RIST also allowed multiple clients to connect to the same port, but the same capability is also available in SRT using Stream ID in the implementation. Now, a new feature that is going to come in RIST, which is, people think it is like the rendezvous point in SRT, but it's actually something totally different. This is something called a RIST relay. A RIST relay will allow clients to connect to an external device that it will hook to a destination or vice versa. It will be, to those who are familiar with High Vision Hub, it's something much more advanced than the SRT Hub because it can provide point-to-point connectivity, multicast capability between selected clients. It will provide more security to organization. So now they can connect to an external cloud service that will allow connection over a single port. And it's simpler to the IT guys to monitor that and block unwanted traffic.
Got it. Thank you.
Thank you.
And as I can see from the chat, we have a question from Norman about 16 channels. Yes, so I've noticed your Skype contact and we know you. We are in contact with you. Right after the meeting, we'll contact with you again. And yes, it's possible to use SRT in CodecWorks for 16 channels. And we'll provide the support. And I'll just notify the responsible for your project and it will be done briefly.
Thank you, Vitali.
There are questions in the Q&A if you want to go over that briefly. Or I think most of them are for Martin.
Yes, there are sometimes, some of them I ask, some of them, but we can proceed with them. One of the questions is about support for redundancy, RIST versus SRT.
So I don't know what redundancy means in this sense, but RIST provides the ability to do load share, meaning that multiple paths, multiple different senders of the same source can connect over multiple different medias, links, and paths. So if one fails, the other will sustain. That can be a full duplication or a partial duplication. So if you're using, you can send, let's say you have 5 different links, you can send 20% over every link. And then if one fails, the other one will pick up, and instead of 20, will be pushing 25%. I hope that will answer the question. In SRT today, because the bonding is still in nightly builds and not officially released, then it's not available. If it is application redundancy, this is a total different story and is nothing to do with the protocol. Okay.
Okay.
Yeah, just to clarify, in case of SRT redundancy, you need to create 2 different connections and to switch over them by the tools that application offers. It's not integrated into the protocol like is already done in the RIST, but probably next release will change that. Let's see.
Okay, thank you, Vitaly. The other question is about ports, like which UDP ports need to be open for RIST, in which direction?
Well, just like with the SRT, you select the port, you select which port you want to use. It needs to be bidirectional. It should be UDP port because RIST is using, the tunnel is using DTLS. If it's a main profile, you open only a single port. The traffic is UDP based, bidirectional, that's it. If you're using a simple profile, then you need to open 2 ports, one for the RTP session and one for the RTCP session. So if you select port UDP port N, the RTCP will be N+1. If you choose to add a further correction, then you will need to open N+2, N+4.
And if I'm not mistaken, multiplexing onto the same port is also available in SRT in the current release. So you just can do the same via only the one port in SRT.
Okay. Okay, thank you very much. So I believe that we are almost done with the questions. I don't see any additional question in the Q&A tab, but anyway, please feel free to send your question to our email and contact us via our website. Well, so thank you very much for attending our webinar. I hope that this conversation was curious and exciting for you. And thank you, Adi and Vitaly and Yekaterina for participation in the webinar. So please feel free to contact us, and I hope we will meet very soon in person. Thank you very much.
Thank you, colleagues. Thank you, Adi, the main driver of our current conference.
Take care, guys. And if you want to meet me at NAB, I will be there somewhere in the video flow booth. Come and meet me. Say hello.
The same to Elecard. Come to meet Elecard at NAB. We'll be happy to have you there. Thanks, everyone, and bye-bye. Have a great day. Bye.
Thank you.
Thank you.
Thank you.
Thank you.
Bye-bye.
Bye-bye.
See you.
Thank you, guys. I don't know if people see us, but take care.
Thank you, Adi.
Thank you. It was a great webinar. Thank you. Yes. It was really interesting.
You've done a huge job. Thank you very much.
You're welcome.
Thank you.
Bye.
Bye-bye.